Don't mind the mess. But welcome to my shop, and today we are going to make a spanning beam lathe table. Hope you enjoy. So let's take a couple minutes and talk about the lathe stand itself. So first, I designed this in Fusion 360, and the overall dimensions for this lathe, which is the Precision Matthews 1030V stand, which is what we're working with, the Precision Matthews 1030V. And the overall dimensions is about 54. That includes the box. Asked a few comments online to some other videos, got some dimensions, some rough dimensions, since the base of it is not really on Precision Matthews website. So couldn't find any of that info, but just wanted to kind of give you guys an idea. About 34 inches tall. That will put the handle right about my elbow length if it's on the bottom of the beam that spans across. So yeah, so since I can't do math, I tried to do miter joints and couldn't figure it out, even though I could do it if I just flipped parts around and used 34 on a couple parts. So highly recommend, if you are building this, go ahead and do plan for miter joints. It's going to be a little bit stronger of a weld connection. This will work just fine because the load distribution is vertical from the stand down. So you're really looking at compression loading, you know, on these welds right in here. So anyway, use some 2x4 tube steel for the main frame. Using a 3x6, ran some quick calculations based upon these point loads coming from the feet on a on a fixed end connection type of a support system. And yeah, so hopefully we'll be able to get this figured out. I did buy these 300 pounds a piece rated stands from McMaster-Carr. These are a medium rubber, and just kind of give you an idea of what it looks like. Might upgrade these in the future depending on how much tool storage I end up putting in the bed itself, but might make that out of aluminum and put some drawer slides just so it cuts down on some of the weight. But anyway, follow along and we'll get the show on the road. 25-inch cross member, gonna weld that to this vertical. Highly recommend picking up one of these or maybe a few of these. These are these magnets that you can turn on and off, which are great. So pick the longest side here. It's really hard to do this with one hand, but these magnets then end up truing these two faces together, and then as well as putting one here in the corner, going ahead and truing up this. Just going to place a couple tacks first, and then we'll flip it up on its end, take some measurements across, make sure it's square. That's it's the easiest way, and then fully weld it out after tacked it in place. Place a couple tacks just right up here in the corners. Should be more than enough. We'll do the other side and flip it up and start truing it together. So once those are welded, I use those magnets to kind of hold this upright. And then what I'm going to do is take a measurement from the left side to the right side. So I put a square up as a reference. Same down here, put another square up as a reference. Measure those 2 points, make sure they're aligned. And then take a diagonal measurement across the part. Same as this side, take that diagonal. And then that'll make sure that you're square. In order to figure out if you're plumb perpendicularly, I'm just using a regular carpenter square, making sure that it's aligned as best as possible. Again, since these are all welded joints and all the loads coming downward, this is not really 100% critical, but we do want to make sure, you know, tighten it up if when we put the cross braces on. So after we squared up the frame, went ahead and welded on these little extra pieces that we had in order to have adjustability for the stand. All around weld for that, and that should be good. Worst case, I could always add some extra, reinforcement plate in order to still access that, but, stiffen it up a little bit more. But because of it being such a slender, object, should be fine. And one thing to note when you do weld, because it is closed at the bottom, because you all around welded that, you do need a vent hole. And if you can see, just that tiny little vent, you'll need that in order to off-gas, the inside of the tube. So don't forget that. You don't want this thing exploding, or when you get to the end of your weld, it won't seal and it'll just keep bubbling out because of that pressure. So vent hole, put the vent hole in. So once you stand up the legs, I used actually these pieces of angle going across and clamping it on both sides, and then raising it to the correct height, as well as checking for square this way, check for square from this beam to the leg, as well as that leg, and then set up a level. I know it's not a big one, but set up a level and true everything this way. And then once you get there, then you can do micro adjustments for where the lathe sits. So the lathe will sit right here and another foot will sit over here. So then we'll be able to shim it this way, as well as just rotate each foot, to get it to perfectly align. But if the lathe comes a little bit twisted, then, we'll be able to shim it directly under here and get the twist out of it. So next is to take these angles and put an angle support going across. I still have to do the intermediate braces, but I mean, this thing is so stout as is that I don't know if we'll need to add that, but probably throw it in because I already have them cut, and we'll just run some temporary bracing from left to right. Ooh, it's been a long day. On to the next part. So just want to do a final recap. Painted this safety blue just to give it some protection against rust. Also welded on some end caps right there. I did have to go back and resand the top surface. My roller actually had some fibers that got loose because the paint is, the enamel is so thick. So just wanted to give a, after it was installed and what it looked like. Storage just temporarily for that stuff, but eventually put some drawer slides on it, as well as some type of coolant catch system. I figured when I get the drip pan for the lathe, it will help design that system in order to run flood coolant and be able to catch it and then recycle it. So anyway, here is the final lathe stand, and thanks for watching.